So by trying to solve x minus y equals 4 and 2x plus y equals 5 by graphing, we can look at the best method or an easy method to graph each of this. We have x minus y equals 4. It appears like we can use the intercepts method in order to graph x minus y equals 4. Okay, so let's try to graph this. First is your x minus y equals 4. Let's find the x-intercept of this. In order to find the x-intercept, your y must be 0. All right, so let y be 0. So when your y is 0, that means we plug in 0 to y. We have x minus 0 equals 4. X minus 0 is x, so that's equal to 4. Therefore, your x-intercept is the point 4, 0. And that can be located in your x-axis. How about your y-intercept? In here, we let x be 0 and we solve for y. So you plug in 0 to x using our equation here, x minus y equals 4. Your x is now 0. So your x be 0. We have 0 minus y equals 4. 0 minus y is negative y. That's equal to 4. Divide both sides by negative 1. Therefore, y is equal to negative 4. So what do you think is your y-intercept here? It's 0, negative 4. So let's plot these points. 4, 0 is somewhere here. It's actually there. 4, 0. How about 0, negative 4? In your y-axis here. And then we connect these 2 points. Let's connect it. Let's connect them. All right. So there's your line. The line x minus y equals 4. That was. Now let's have 2x plus y. Let's also graph 2x plus y in the same Cartesian plane. And let's see how we can read the solutions out of the graphs. In this case, we're graphing 2x plus y equals 5. We can also make use of your intercepts here, or we can use other method. The x-intercept is not integer, right? But let's see if we use that x-intercept. Why not? As long as we can plot the intercepts accurately. 2.5 or something like 3.5 can be plotted accurately, right? Because you know it's in the middle. Let's start with your x-intercept. Here we let y be 0. So using this equation now, 2x plus y equals 5. Your y is 0, so we have 2x plus 0 equals 5. 2x plus 0 is 2x. And divide both sides by 2, you have x is equal to, or 5 divided by 2. What's 5 divided by 2? 2.5. All right. X is equal to 2.5. Therefore, your x-intercept is 2.5 comma 0. Can we locate 2.5 easily? Where is that in between? It's in between 2 and 3. Exactly halfway between 2 and 3. Well, if that decimal is can be easily located. Otherwise, if you have a decimal like 2.01, oh, that's so hard to locate, right? But 2.5, we know it's halfway between 2 and 3. So in this case, we can make use of the intercepts. How about your y-intercept? Here we let x, not x, we let y be 0. So we now have, oh my goodness, it should be x. What am I doing? We already did that a while ago, right? Okay. So we let x be 0 and then solve for y. So we have 2 times 0 plus y equals 5. 2 times 0 is 0 plus y. 0 plus y is y. We have 5. So your point would be 0, 0, comma 5. All right. So let's plot now 2.5 comma 0. Where is 2.5? It's in between 2 and 3. Here, exactly halfway between 2 and 3. Where is 0, 5? It's in your y-axis. So it's somewhere there. All right, so this is 0, 5. Let's put the coordinates. This is 2.5, 0. I forgot to put the coordinates of our first 2 points. This is 0, -4. This is for 0. And now let's connect the points here for these 2 points. And that is our line, right? This is the graph of 2x plus y equals 5. And the other one is the graph of x minus y equals 4. And what do you notice? Any observation? They meet at one point. They meet where? They meet here. And what do you think is the coordinate of that point? It's going to be 3, 3, -1. And what do we call this? It's the solution of the system. So they intersect at 3, -1. So the solution is 3, -1. The ordered pair 3, -1. Always look right first x coordinate followed by the y coordinate. Since they intersect at one point, these two lines intersect at one point, they have a solution. There's only one ordered pair that satisfies both. When you plug in these values, 3, -1 to your x and y in both equations, you will form a true statement. And since the solution is 3, -1, there's only one point of intersection. We call this system the independent system. All right, so take note of that. This is an example of an independent system. Independent system is a system of linear equations in two variables that intersect at one point. And also, an independent system is a system with only one solution, and that solution is an ordered pair. Example is 3, -1.